Okay, so we are looking at DynamoDB, and at this stage now, I suppose everybody has probably, if I go to the website, we're in here. I guess everybody has completed or should have completed this lab now. So to an extent, the beginning of today's lecture is slightly behind the lab, but that's okay. And next week lab, strictly speaking, is this one here. So I want to finish off these slides. And then move on to the next topic. So yeah, we have a sense now of how to create a DynamoDB table and also how to get a Lambda function uh, talking to DynamoDB. So here's our stack file. And here we've got a table, got some more stuff here we don't care about for now. We've got a Lambda function that reads from that table. We're still triggering our Lambda using a URL generated by the Lambda service. We'll change that from today though. Now, what I actually want to focus on for a moment is, let's say, this line here. And it's kind of obvious from just reading the syntax. What the purpose of the line is to, its purpose is to give the Lambda, as in this Lambda, give it read access to this table. Now, how does that actually translate when we deploy? So if we go to the Lambda service, and if we pick out the Lambda that we're interested in, which is this one. And if we go to the configuration part, and then the permissions part. So I talked about this idea that a Lambda has an execution role, and that controls what other services the Lambda can communicate with. And the CDK will automatically generate an execution role for each Lambda. And so here it is here. And it assigns policies to that role. And this is the default policy that every Lambda is assigned. And I spoke about that before. This policy allows the Lambda to essentially communicate with CloudWatch logs. Yeah. But there's a second policy now assigned, and this policy was generated by the CDK when I did the CDK deploy. It's generated, and in other words, it's kind of added to the CloudFormation template by the CDK framework as a result of that line of code that I was highlighting there in VS Code. And so if I go into the generated policy, this is kind of a custom policy, I guess you'd call it, for this specific Lambda. And in JSON form, here is the policy itself. Yeah. And here are the different actions, I suppose, that the Lambda is allowed to do, perform against DynamoDB. Yeah. So, and it's given it quite a lot. It's given it, a number of like these are actually endpoints here. These are endpoints in the DynamoDB service. Remember I said that each service has a web API interface with various endpoints. And so these are kind of the endpoints that our particular Lambda has access to. Now, arguably, you know, it has given it more privileges than the Lambda needs. I haven't shown you the Lambda function, but you know it from the lab. All the Lambda does is it tries to get an item from the table. So kind of strictly speaking, the only uh, permission it requires is this one here. Yeah. And you know from last year's module on DevOps, you know that you don't over provision, you don't uh, allocate uh, too many permissions to anything really. In this case, to a Lambda function. So uh, I suppose it could be argued that the CDK is giving our Lambda too much permission, and so if we want to try and remove that, then really what we have to do is write our own IAM policy and attach that policy to the Lambda. And that's something you may want to do, not specifically with Lambdas, but more generally in your CDK stack code. You want to be able to customize IAM policies. And so how do we do that? Well, if I go to my stack file and I have a piece of code here that I've commented out. So if I uncomment it, and so here's my Lambda reference, and I'm adding to the role that's the execution role for this Lambda. And here I'm creating a new IAM policy. You know, so this is just the syntax, right? That's all I'm really showing you. Now, what I actually did was I just grabbed these, right? Grabbed all of these and copied them over here, and then I kind of one by one took out ones that I thought it didn't need, and it turned out that the only one it actually needs is that one. Sometimes, you know, even though the Lambda is only doing a get item from from the table, you know, clearly it needs this permission, but maybe this permission is dependent on some of the other permissions as well. But it didn't arise in this case. So now I am just generating a policy that just has one permission related to accessing DynamoDB, which means I can now, technically, I can actually get rid of this line. And if I now do a deploy, uh, always the CDK always checks to see, are you now changing some IAM policies which potentially have some security implications? So it always kind of checks with you. Are you sure you want to do this? So even though I'm reducing the permissions rather than extending them, but so I let that deploy. I don't know, does it generate a new policy or amend the existing one? But either way, the end result hopefully will be what we want it to be. So it has deployed at this stage, and if I now go back and check again, here's my role. And where are we? Oh yeah. Here's the new policy, hopefully. And yeah, did that work? Yeah, so here's the only action that it's now allowed to perform. And hopefully it still works. So if I go to Postman, if I go to Postman, all right, just let me check one thing there. Whenever I see Slack messages, I'm wondering, is that somebody? Okay, I'm not going to read those. No, sorry. Can I just check that people can hear me and see my screen? Can somebody come back to me on that, please? Nobody's responding. Just wondering, are you still there? Yeah. Okay. That's good. That's a new feature in Zoom that I didn't know. Where am I? I want to share again. Oh yeah, so I want to test my Lambda to make sure it still works. Sorry, back to Postman. So I've set this up before the lecture, obviously. This is the Postman collection that I have for myself. This is the Get Specific movie. Okay, you'll have to take my word for it. Um, this is the actual endpoint that's being tested here. And if I do a send, yeah, yeah, so it's still working. Is that right? Yeah, it is. Yeah, it's still working. It's got movie 1, 2, 3, 4. Okay, so anyway, that's uh, that's kind of a typical example now of kind of the the neatness in my view, like of the CDK framework, as in, just a single line of code. Where was our single line of code? This single line of code, generates, uh, in this case, IAM policies and roles behind the scenes for us. Um, right, that's really the main point. Okay, back to the slides. Oh, they're the wrong slides. Oh my gosh. Switch to these ones. Yeah. Now, remember I said that a DynamoDB table has a primary key, which you must declare at table creation time. That primary key can either be a simple primary key, which means it consists of one value. That value also plays the role of the partition key, and I explained what the significance of the partition key is. The second type of primary key is when it comprises of, or it's composed of two properties of your table items. One of those is still has to be the partition key property, and the other one we call a sort key. And the requirement is that the partition key and sort key combination has to uniquely identify an item in your table, i.e., it has to be a primary key. So there's this primary key and partition key. They're kind of, they can be the same thing in some cases. They can be slightly different in other cases. I also said that where did I say it? Back here, that when we want to query a DynamoDB table, queries actually only work with tables that have composite primary keys. And here I'm saying that when you want to query such a table, you must specify the partition key value in your query. So the partition key, the only thing you're allowed is to say, the partition key is equal to a particular value. You can't have something like, I'm only interested in items where the partition key is greater than or less than, those operators aren't available to you. It has to be equals. The sort key part, you have all of these operators available to you if they make sense. Now, clearly, these ones would only make sense if the sort key is a numeric value, and if that numeric value, is not something that's kind of randomly generated. So you have all of these operators anyway available to you. If the sort key is a string, then the only operator that you have available to you is begins with. So you could say something like, I'm looking for items from my table where the partition key is exactly equal to 1, 2, 3, 4, and the sort key begins with ABC, right, or something like that. So it's quite restrictive. Like, you can't say I'm only interested in items where the sort key ends with something or contains a substring within it. That's just not available to you. So the querying is very restrictive in DynamoDB. Sometimes people don't grasp that, but early on anyway. It's only when they start doing things and querying in DynamoDB table, they realize I can't actually do this. Now, the out is kind of this here, right? You can specify what's called a filtering expression. And the filtering expression can be based on other properties of your item other than the partition key and sort key. So let's take an example, right? Supposing I have a table, I think it's on the next one actually. Here's my table with customer orders, and the partition key is customer ID, and the sort key is order ID. And even though the order IDs here look kind of meaningless, let's supposing the order IDs were kind of sequentially numbered. So you've got, order number 10, 11, 12, this kind of stuff. So for this table here, right, a query could be, give me all of the orders where the customer ID is a specific value and the order ID is greater than 200, okay? And it will return that. That's a valid query. You can also say, give me all of the orders where the customer ID is 1, 2, 3, 4, and the value of the order is greater than 200. But that greater than 200, the value greater than 200, or the amount, let's say, greater than 200, that has to be stated in this filtering expression. Now, the thing though is that the filtering is not carried out by DynamoDB. What DynamoDB will do in that case, so my query again is, I want all orders for customer number 1234 where the amount of the order is greater than 200. What DynamoDB will do in that case is it will return all of the orders for customer number 1234. And on the client side, it will do the filtering. So you are actually, all of the orders are being sent across the network from DynamoDB to our Lambda in this case, right? But the DynamoDB SDK, that's going to reside on, as part of our Lambda code. It will actually perform the filtering. The DynamoDB SDK will do the filtering. But all of the data has already traveled from across the network from DynamoDB to your Lambda. So it's not as efficient as you might think. Right. And the reason all of this happens is because, DynamoDB can only accept queries based on these two values. Right. Are there any questions about that, I wonder? No, okay, I'm going to keep going. There are some other restrictions. Just before I move on to the other restrictions, I did say to you before that DynamoDB frontline, you'd say it's a non-relational database. Oh yeah, that's fine. I know stuff about non-relational databases, but it has some characteristics or qualities to it which make it quite different from most other, if not all other non-relational databases. And this kind of stuff that I'm talking about here, the kind of how restrictive the querying is, that's part of DynamoDB's model. DynamoDB, as I mentioned to you before, was designed for large databases like tens of, maybe even hundreds of gigabytes of data in size, and it's highly performant for that size of database. But the downside is this kind of querying restriction. Okay. Other restrictions on the querying is the query result, if you like, or the response. You're limited to 1 megabytes in size. If you know that the response to a query is going to be greater than that, you can specify limits so that it falls within the 1 megabytes. Also, it actually it 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 can actually support pagination. So when you retrieve a large number of items in a response on the Lambda side, and we're only interested in Lambda, but it doesn't really matter what the client side is. Your Lambda, you can code the Lambda so that it can paginate through the results that have been returned back. In, let's say, groups of 10 items at a time. Okay, this is just reinforcing sorry. This is reinforcing what I've just been saying. You can only query based on these two fields. Okay, you cannot query based on these, but you can request filtering on the base of these. But I've already told you the filtering actually, it kind of happens too late, really, in a sense that it happens on the client side. It doesn't happen on the server side. Now, you've seen this in the lab, okay? So to illustrate some of this stuff, if you remember, we have a table containing movie cast information. The partition key is movie ID again. And I just arbitrarily decided that the sort key is actor name, which is a string in our case rather than numeric value. That's fine. I think I would have said somewhere to you that you can't just sort of decide after you've created your table, oh, I'm actually going to change the sort key to something else. If you find yourself doing that, then you have to essentially destroy your stack and start all over again. That's DynamoDB is restrictive in that sense as well. In most other cases, when you make changes to your CDK stack code, you can just do CDK deploy and CloudFormation will update the stack. But there's no sense of updating your table design. That doesn't work. And here is an excerpt from our Lambda function. Again, you've seen this. Because we have a composite primary key, then we can execute a query against it. We can also execute a get command against this table, okay? But I'm just illustrating a query. And okay, we've got to indicate what table we're talking about. And here's our, here's kind of an indication now that we're not only querying on the basis of the partition key, but we're also querying on the basis of the sort key, which is actor name in our case. And you can kind of work out from the syntax. So the sort key is a string, so we have this option of begins with as a querying condition, if you like. Syntax is a bit clumsy in that you specify the actual values that you want to associate with the partition key and the sort key. You assign the values in this, what's it called, the expression attributes. You don't kind of put them up here. You can't put the actual value up here. I think syntactically it doesn't like that. And I'm hard coding them here, which is also not great, but typically you can put variables here, obviously, and the variables might come from somewhere else in the Lambda. The assumption now is that this is part of your Lambda. And as I said, you have stepped your way through this in the lab anyway. So I'll kind of assume maybe that I don't need to show you that. What's on the next slide? Okay, now because of the restrictive nature of querying, then what DynamoDB gives us is what it calls local secondary indices. And a local secondary index is an index which has, again, a composite primary key part to it. But in this case, the sort key can be something other than what you declared when you declared the table. So again, if I go back to here, here we have the sort key is actor name, but I can actually, I can request that a local secondary index be defined in addition for this table, where that index's sort key is going to be something other than actor name. And then I'll be able to run queries using that local secondary index. The partition key part of the local secondary index has to still be movie ID in this case. And we saw that in the lab where we had, in the case of the movie cast, we had the role name as the alternative sort key. In the main table, I have actor name as the sort key, but in the local secondary index, I have the role name, the name of the character in the movie. Yeah. There is a maximum of, where do I say it? A maximum of 5 LSIs that you can define for a table. LSIs, oh yeah. Now, so an LSI, an LSI has the same partition key as the main table. And we know what the significance of the partition key is. The partition key of an item determines which partition of your database an item is written to. Now, if the LSIs are using the same partition key, then that means that the LSIs are actually stored in the same partition as the item they refer to. Yeah. Okay. If I just say more generally, let's supposing I've got a table with 5 GB of data. If I define an LSI, a local secondary index for that table, the database is now going to increase to 10 GB of data. When we hear the word index, we think about this idea that the index has a key part. The key would be our partition key plus our alternative sort key. And then the value would kind of point to the table item. That's how we kind of naturally think of indexes. They contain references to somewhere else. In this case, they contain references or a pointer to the actual item data in the main table, let's say. But that's not how local secondary indexes work. A local secondary index is a complete copy of the entire table. So again, going back, if I have a table with 5 GB of data and I decide to define a local secondary index, one local secondary index for that table, then the table size is now going to double. It's going to be 10 GB of data because every item that is written to the table, the main table, that item will actually be written to the local secondary index as well. And why does it do that? Why did they decide that in the design? It's to speed up the response of querying against the local secondary index. Now you can, in your table design, you can say, I don't want every property of an item to be copied into the local secondary index. You can itemize them. You can say there's only specific properties of an item that I want to have copied into the local secondary index. That's referred to as projections. So when you define a local secondary index, you can associate with that index in the definition of it the projection part. And the projection is where you would specify what properties of items from the main table should actually be copied into the local secondary index. If I go back to my code for a second. So I have my movie cast table here, and here's how we defined our local secondary index. And I've decided that my sort key, my alternative sort key is role name, character name, let's say, a role name. I'm not specifying a partition key here because it's the same partition key. I do give the name, I do give the index a name because that will be used when we query. When we query this movie cast table, we have to tell it, well, which index are we using? Are we using the main index or the alternative index? If you don't specify any index, then it assumes it's the main. And this is the end of my local secondary index definition, right? So I'm not actually making any statement about this projection part. And that means that my local secondary index will have all of the data from what I'm going to call my main table. Sometimes we refer to this part here as the main index, and this is the one of the secondary indexes. This is kind of stuff that's happening behind the scenes, like this idea of all of the data from the main index is copied or projected onto the local secondary index. This is all happening behind the scenes. We could happily write um, write serverless applications and not necessarily know this is going on, but I think it's good to have that kind of knowledge at least a couple of levels below the programming level. Um, what else? Oh yeah, that's okay. LSIs, your LSIs, and you can have up to five, as I said. They must be defined at table creation time. So you cannot, having deployed your stack, you cannot then add another local secondary index after the fact. That's simply because some items have potentially have already been written to the table, and DynamoDB now can't start creating new LSIs and doing projections on them. It's just they decided, look, that's not going to be allowed. So you have to design your database upfront, which is always a good idea anyway. Each LSI entry, oh yeah, there's the word projection. Yeah. It's a projection of the table item itself. So I've kind of explained that now, hopefully. And yeah, I've said it. So now that means a table has a primary or main index, and optionally it has up to five LSIs. There are also there's a notion of what are called global secondary indexes. We're not going to look at them, but with a GSI, you can specify an alternative partition key. Um, the GSIs, though, they are not stored in the same partition. They're kind of stored separately. And clearly, these GSIs extend the range of querying that we can do against our table, which is really what these LSIs and GSIs are all about. This is just, I think I took these straight out of the DynamoDB documentation, to be honest. So this is Maria, a table, what is it? A table of discussion threads for a social media Maria application. And the discussion threads are all about different AWS services. So this is kind of, let's call it the main index, okay? The partition key is forum name. So that looks like it's the name of an AWS service, actually. So they would be unique. And the sort key is the subject of the thread. Yeah. Whereas here I've got an LSI. Again, the partition key is the forum name, i.e. the AWS service name, and the sort key is the last date, as in the last date somebody posted, I guess, a uh, a discussion item on this particular topic. Yeah. Now, DynamoDB does not support the date type natively. So really this date has to be interpreted as a string. And so the only kind of querying we could do is specify the exact date, or we could say, I'm only interested in threads for what is it, the for the S3 service where the date begins with 2025 or something like that. And finally, in the Lambda that we used for querying this table, again, you've kind of hopefully studied the code, but am I looking at the right one? Yeah, okay. So you remember I arbitrarily decided that, so this Lambda has a URL, and the URL can have a query string added onto it, where the query string can specify a movie ID and either an actor name or a role name. Okay. And so that's why, we're taking the query string part from the event object. So we have access to the query string that was sent across the HTTP network, and we're extracting. What are we doing? We're checking first of all that it does have a movie ID in the query string, because if it doesn't, we can't do anything because that's our partition key. And then we are we're checking. What are we doing here? We're checking to see, does the query string have the actor have the role name? Sorry, does the query string have the role name in it? If it does, then I want to query my database against this index, which is the name I gave the LSI in this case. Else, the else assumes now that the query string, is that what I'm doing? It assumes that, oh no, this is the else here, sorry. Else I'm checking to see, does the query string have the actor name in it? And if it does, then I'm querying my database against the main index, but I don't have to specify the main index because it assumes that. And the third else is when the user just says, give me all of the actors stroke roles for a particular movie. So they've only specified a movie ID in the query string, no actor name, no role name. And that's about it. Are there any questions about that? I'm not spending a lot of time looking at this code here now because you already have this code from the lab. And the assumption is that, you've taken some time just to study it to make sense of it. Admittedly, we hadn't covered LSIs, so you may want to go back and just quickly review this code from the lab yourselves. There was uh, I can just do a quick kind of demo. So here's my Postman collection again. And here I did this before, obviously. So the the lambda that we're looking at is the lambda that is querying the movie cast table, and that lambda has a URL, so that's the actual URL. This is the URL of that lambda. That's okay. And here's my sample query. So, here's the kind of query string possibility: movie ID equal to 1, 2, 3, 4, and role name equals male. And the way my querying was specified, I'm using this to say, look for any role name that begins with male. Isn't that what we said? If we look at the code, yeah, you can see there, right? I'm saying I just arbitrarily decided, look, I'm going to use the begins with rather than exactly equal to. Okay, there are my two query string options. And if I click go, and it's giving me back that there were two characters in this movie where the role name or the character name began with male. That looks like it's right. And if I change it to female, you'd have to see the C data, obviously, but take it from me that where's female? And click go. And looks like there was only uh, one item where the role name began with female. Didn't actually check it to see if I take this out completely. So it's only movie ID, then I should get back all of them. Didn't test it. Yeah. All right, so that all seems to work okay. So that's LSI's covered. And yeah, that's all I want to look at really in relation to DynamoDB. This is quite I think it's about a 25, maybe 30 minute video that I found online where he kind of, again, kind of explains LSI's. So you may want to have a quick look at that. It's not too long. Right. Let's move on our serverless journey. And I want to look through these slides here. So up to now, our lambdas have, each lambda has a custom, well, not a custom actually, it has a generated URL, and that allows us to invoke the lambda over HTTP. But it would be nice if all of my lambdas had a kind of common entry point, and that's really where web APIs come in. So that's what I want to talk about next. And of course, it's web APIs that are serverless in their nature. Now, we know a lot about web APIs from the Web App Dev 2 module that you studied last year. And so really, we're just taking that idea. We know what REST means in the context of web APIs. You need to go back and look at your notes if you need to refresh on that. So we're taking all of that knowledge as understood. And all we're really interested in here is, well, how do I create a serverless web API on the Amazon platform? Just to be sure, the whole idea here now is that we've got some functionality that's available, that's running on the server side. In our case, it's Lambdas. And we want to have a uniform interface to the various Lambdas so that any of these kind of clients can trigger the execution of the Lambda. But this is I guess this is the part that we're interested in. How do we create this in a kind of serverless mode? And the answer is use the AWS API Gateway service to do that. So it generates RESTful web services, or what it refers to as HTTP. They're kind of similar, except these ones are actually cheaper to use. You're not charged as much for a HTTP resource as you are for a RESTful resource, but these ones have more kind of knobs that you can tune. We will look at these ones, but they're quite similar to create anyway. This is just an image that I found somewhere on the web, and I said, okay, that looks nice. So we're talking about creating a serverless. When you talk about a serverless app, um, then there are kind of three parts to any serverless app, and this isn't necessarily web APIs now, but any kind of application that's running on the server side and it's serverless in nature, and we know what that means. Well, any app has to have some functionality or logic. And so we now know, well, the Lambda service is the service that you use for uh, deploying the logic part of a serverless app. In terms of the state management, we now know that one option available to us is to use DynamoDB. We could use S3 as well because, maybe our application allows us to upload files and that kind of stuff, and we would not be storing files in the database, so we'd use the S3 service for that. And I'm just showing you this one here. If you don't want to use a non-relational database, if you want to use a relational one, then there is this RDS service, which is a serverless relational database service that we could have used. So that's the state management side. of your serverless application. And the last part then is what's more kind of generally referred to as communications. And so one service, which is the one we're looking at now, is the API gateway. That's kind of comes under the heading of communications in the sense that it allows the end user, I suppose, to communicate with your Lambda functionality. These other services here are more about kind of Lambda to Lambda communication. And we will look at SQS and SNS later on in this module. That's where kind of API gateway fits in this overall server-side serverless application. So again, fully managed, to say that API gateway is a fully managed service is a byword for serverless, and you use it for both creating your web APIs, although we're going to use the CDK, but you can use the management console for creating your web APIs, for maintaining them, as in, adding to them and et cetera, et cetera. You can also use API gateway for monitoring your APIs in terms of usage patterns and all that kind of stuff. We won't get to do that. Obviously, there is a security aspect to it. So you can make certain endpoints in your RESTful Web API private, et cetera, or maybe the request requires some sort of token in order to ensure that the user has authenticated themselves before they can actually access the endpoint. Both RESTful and what, as I said, what AWS calls HTTP, which is kind of a lightweight, if you like, a lightweight form of pure REST. It does support the WebSockets protocol as well, but so that WebSockets, as you know, would be for server-side push notifications. So here is kind of your classic three-tier architecture, and this is really what we're kind of going after, where you've got API gateway, that's your interface for your clients, sorry, all of these guys here. And behind the gateway are your lambdas. Of course, and there are going to be many lambdas, obviously. The assumption always is, it's not that API gateway is talking to your lambda. It's always going through the lambda service. So really API gateway is talking to the lambda service, and the lambda service triggers the lambda. We kind of take that for granted from here on in. I hope I don't have to keep repeating that. And as we've been talking about, our Lambda service in our case is just talking to DynamoDB. So that's your classic kind of three-tier architecture, which is exactly what you would have developed in the web app dev. You would have also developed the client side using the React framework, for example, a web client. So there's a lot to this API gateway, and to be honest, a lot of it we won't get to look at. But so it does support versioning. So what that means is you can have multiple versions of your web API active at the same time. Yeah. So maybe the very first iteration of your web API, let's call it version 1, then you made some upgrades to it and now have version 2. But some of your customers or some of your client-side applications, we still want to use version 1 because otherwise we'd have to go updating or changing our client-side applications as well. But our newer client-side applications want to use version 2. So we want API Gateway to be able to allow both versions to be accessed at the same time, yeah? And that's kind of built into, you can configure API Gateway to take care of that. So it supports versioning. It also supports different environments, as in, you might want to have a dev environment separate from test, separate from prod, and you want all of these or some of these to be available at the same time. You don't want to have to kind of shut down the dev version and then boot up the test version of your web API. You'd like to have them running concurrently if you like. So it does support that out of the box as well, subject to some configuration. Handles security, that's taken for granted. You can get it to generate API keys. You might remember API keys from last year. So the idea there is that the client maybe would first of all request an API key that's kind of as part of the registration, and then that client always uses that API key as a form of authentication. And then maybe your API gateway would check to make sure that if the client is trying to access a particular endpoint in your web API, they must provide a valid API key before they're allowed to trigger the actual backend Lambda. And you can associate what's called you can associate a policy with an API key. So the policy might dictate how many requests per minute or whatever the client is allowed to issue against your web API. And if they exceed that limit, then they get a throttling response. So you can control the user's activity via what's called a user plan that you associate with an API key. Swagger, you may have heard of Swagger. What you can do, Swagger is a language for specifying a web API, and you can give API Gateway a Swagger document, and it will generate uh, the necessary API Gateway resources. Now, we don't need to do that because we're going to be using the CDK, but it does support Swagger as well as OpenAPI, which is an alternative to Swagger. Supports for WebSockets, I mentioned that already. I'll come on to this. Oh, sorry, no. You can get API Gateway to do a certain amount of validation of the request. If the request is a post request, which means it will include some sort of payload or body to it, and maybe you want to validate the structure of that body before you pass it on to your backend, whether that be a Lambda or not. You can get API Gateway to do that validation. Some people argue that it shouldn't be doing that. That validation should really be performed by the backend, but it's an option that's available to you anyway. You can also get API Gateway to carry a transformation of the payload before it passes it on to the backend. You can even get the gateway service to generate an SDK for your web API. And the benefit of that would be that rather than your client code making raw HTTP requests to API Gateway, it would actually be making kind of method calls using the SDK that was generated for your specific web API. I've never actually looked at the code that it generates, but it's there anyway as an option. It does support caching as well. I played with it a little bit. I didn't find it great, but we'll just leave it at that, really. It was quite difficult to configure, I found, and it does have DDoS protection options built into it as well. So lots of configuration parameters available to you. Now the heading here is, sorry, let me just check my time. Oh yeah. The heading is integration types. By integration types, I'm talking about the integration between the API gateway service and what's kind of at the back end. Yeah. And there can be anything at the back end. Like if I go back to this slide here, there are more options than just having Lambda as the back end. And so so when we talk about the integration types, we're talking about the integration between, as I said, API gateway and whatever the backend is. And the nature of the backend kind of dictates the integration type option that you pick for your RESTful Web API or HTTP API. And I'm just documenting them here. So there is a kind of default one called a mock integration. Sometimes you may want to define your web API or part of it, but you actually haven't got the functionality at the back end developed yet. And so in that case, you can actually associate what's called a mock backend with particular endpoints in your web API. So that's an option really, as kind of a development option. Now, here's another one. Now, what I find when I read up about these things is that there's no consistent name for them. So some documentation refers to this integration type as HTTP AWS. Other places you'll see it referred to as the AWS Services Integration type. Either way, what it means is that the backend certainly isn't a Lambda. It could be something like an SQS queue. And so the idea now is your client, certainly for post requests, your client sends a post request to API gateway, and the API gateway will pick out your particular API implementation, but it needs to carry out a transformation of the request before it can actually pass it on to the backend or SQS queue in this case. You can't make a HTTP request. You can't send a HTTP request to the SQS service. So there has to be some sort of transformation of the request made before you can send it on to the backend. And you can define how that transformation is performed by means of what's called a mapping template. These mapping templates are written in a language called Velocity, and take it from me, they're quite clumsy things to write. So it's not a nicely designed part of this API gateway service. But for now, given that we won't actually be doing this, I'm just making you aware that there is this integration type called HTTP/AWS or this. But if that is the type of integration that you want for one particular endpoint in your web API, then you have to code up a mapping template and attach that mapping template to your web API. That's kind of what I'm getting at there. This is the one that we are interested in. So this is integration type number 3. And it's either called AWS Proxy or it's also called Lambda Proxy. And clearly from its name, this is the integration type that's appropriate when your backend is a Lambda. And what the API gateway will do is it will take your HTTP, so it understands HTTP protocol. It takes your HTTP request and it creates the event object that a Lambda expects. We know from what we've looked at so far that our Lambda handler function, there are 2 parameters. We haven't used the second one, which is the context parameter. The first parameter is the event object, which is just a JSON object. Now, that JSON object is actually created by API Gateway for you. It takes the HTTP protocol request and generates the event object. And then that's how it then kind of gives that to the Lambda service, and the Lambda service passes the object when it invokes your Lambda. And you don't have to do anything special. Once you indicate that the integration type is this, then that kind of logic is built into the API Gateway service. It does that transformation for you. So you don't have to go messing around with these mapping templates in this case. But we know a lot about the HTTP protocol. A HTTP request will contain lots of headers, HTTP headers. It may contain a query string part. What's nice is that Gateway will put all of this information into the event object that it makes available to your Lambda. So your Lambda now has access to all of that information, and that may be important to it. It may need to actually examine some of the HTTP headers, and the values of those headers may control its behavior. So this is the fifth integration type, I think. This is okay. It's either called that. I don't think there's an alternative name. All that's happening here is essentially API gateway is just taking the HTTP request, and it's sending the exact same HTTP request onto the backend. So the backend, one example of an appropriate backend here would be a load balancer. We know a load balancer uh, understands the HTTP protocol. So in this case, our gateway just simply proxies the HTTP request onto the backend. No transformation required or anything like that. Um, so the upshot of it all is that the only integration type that we're interested in, because we want to be purely serverless, is this one here. Um, you do need to specify the CORS configuration for your particular web API. And I'm just reminding people here of what CORS is all about. The kind of image is showing us, supposing we've got a web client application, let's say written in React. You may or may not know that you can actually deploy a React app to the S3 service. Um, we may do it at the very end, but either way, you've got a client-side app, and let's supposing this is the domain name for your client. Over here, we've got a web API, and it has a different domain name. And the whole idea of CORS is if this client, which has a different domain name from the backend, if it wants to send requests to that backend, the client, first of all, has to kind of essentially ask the backend or the API, do you accept requests from domains other than your own domain? And in this case, because our API is sorry, because our API is using API Gateway, API Gateway will respond back telling it what domains it accepts requests from. So you need to configure. That's what I'm kind of trying to get across here. You need to configure the CORS settings for your web API. That's kind of mandatory. I don't think there is a default CORS configuration. So that slide is really by way of recalling this whole CORS thing. Demo time. Let's suppose we have a boring web API that manages to-dos. And these are the endpoints that I have defined for my web API. I want to have uh, a slash to-dos endpoint, which supports either get or post requests. Get, if it's a get request, then I guess the idea is that it would return all of the to-dos in my database. A post is when I want to add a to-do. And I also have this second endpoint, which allows me to specify a particular to-do where this is the path name and there's only a get option there. I've added in some query strings just for illustration purposes, although having thought about it, the query strings kind of don't make any sense. They probably should have been associated with this one. So either way, anyway, these are the endpoints of my web API that I want to create using the API Gateway service. Um, let's look at the code, the CDK code to do that. Now, um, I'm not really interested in the, having a to-do database and having lambdas that are reading and writing to the to-do database. We've kind of covered all of that stuff already. So just for purely for convenience, I just have one lambda in this at my back end, and the lambda doesn't do anything other than it just console logs the event that it receives. And that's kind of that'll be useful to us because we do want to see what is the structure of the event object that has been essentially generated by the API Gateway service when it receives a HTTP request. So that's all my Lambda does. And so what I've actually, again, just purely for convenience, each of these endpoints, the get, the post for slash to dos, and the get for slash to dos slash this, they all go to the same Lambda. Okay. So how do we actually generate the API resource itself? And that brings us to the stack. And at this stage now, it kind of has a kind of familiar kind of flow to it. Okay, this is my Lambda function. Not interested in that. Here's where I start off. I want to create essentially an empty RESTful web API. Some default settings. I am saying that remember I said that API Gateway supports a number of different environments, dev, test, prod. They don't have to be called dev, test, prod. You could have a staging environment. It can be any string really, but so here's, for example, here's where you specify the environment that you want to have associated with your particular web API. So I've just arbitrarily decided that dev will be the environment. And most of the other stuff I don't think is too interesting. Here's the default. You have to define the default CORS configuration. So I'm essentially saying that I'll accept requests from any domain. And do I specify the methods? Yeah, I'm accepting pretty much all the HTTP methods. So that's how I declare that I want a web API, but now I have to define the individual endpoints of that web API, and it's a RESTful web API. And so the way you do that is, again, fairly straightforward. API here refers to that object that was returned. Yeah, API. And what I'm doing here is I'm adding a new endpoint to the root of the web API. And the endpoint string is going to be to-dos, because that's what my specification on the slide said. So that creates the endpoint, if you like, that statement. You then need to, although it refers to it as a resource and an endpoint is kind of the same thing in this context. You then have to attach the particular methods that this resource or endpoint supports. And so that's what I'm doing here. I'm saying it supports a GET request. And here's where we're specifying the integration to the backend. And there is a convenience function, fortunately, called Lambda integration. And there are no prizes for guessing what the nature of the backend. And my Lambda integration, I'm referring to the Lambda function that I defined at the top. Simple as that, really. I'm also adding on the post method support for the same endpoint. And here's where I'm adding and creating a new endpoint or a resource. So I'm adding a resource or an endpoint, but I'm not adding it to the root. I'm adding it to the resource that I've already created. So the thing that I've highlighted here is essentially the first resource because that's what my specification said. Yeah, it said this endpoint here, is obviously an extension or an addition onto this endpoint. And because the path part of this endpoint, uh, I'm assuming people are kind of au fait with when I put curly braces around this, that means that this is a path variable. You might remember that from the web app dev module, as opposed to a static string. So this part of the path is a variable, and we use the same syntax in the CDK code. As you can see here, right? And you can give the variable, this is essentially a variable name, movie ID, and it can be anything you want it to be. It doesn't have to, it doesn't have to match the partition key of a table or anything like that. It's just purely a variable, and hence you can call it anything you want to. So that entire line now has created a new endpoint stroke resource, which in this case is added on to the existing resource. If we change it to API/root, then it would be an extension of the root itself, and you can do that. It's not that you can only have one extension to the root, you can have many extensions to the root. And again, our method support, again, is a get in this case. So and that's all I have in this stack. So it's just a function and my RESTful Web API. I don't have to explicitly output anything from this stack. When you create a RESTful Web API within your stack code, then the CDK will, when you do a CDK deploy, the CDK will tell you what the URL of your Web API is. And I did that earlier on. So when I did the CDK deploy, it's telling me that this is the URL that it generated for your Web API. And so if we switch over to console and go to the gateway service just to see what has been generated. Select, and I only have one API, Web API at the moment. Here it is. No, it isn't. I'm in the wrong region. That's why I got the prompt there, actually. Let's change to a different region. Okay, here's my API. And you have a nice kind of visual representation of the structure of your web API. Yeah, so here's the root. Here's an endpoint that's an extension of the root. Here's an endpoint that's an extension of this endpoint. Yeah. And if we select any, here are the methods that are supported. The option method is always available for any endpoint. So but if I select any one of these, like we're kind of told here, right? This again, this kind of graphic tells us what's the nature of the backend, which is a Lambda in our case. So that is as a result of me using the Lambda integration in my CDK code. And there's other stuff, other information as well that you can poke around and have a look at. But uh, in order to trigger it, I'll do it from Postman. So I need to just grab this URL, which I've already done, go into Postman, and I have a collection here pre-prepared. As before, I have some variables. Where are my variables? Why can't I see? Oh, sorry, variables here. So I did find a variable called that, set it to the URL. That's fine. And so let's do a post. So I'm sending a post request to my base URL slash to-dos. And here's the payload of my post. And I go send. Okay, so message got back success. That response came from my single Lambda, which doesn't do anything, as I said. Um, sorry, yeah, there's the response that came back. But what I'm interested in is looking at the event object itself that was created for me. Yeah. So if we go into CloudWatch logs, and this is the stream. Yeah, this is the log group. So again, there's a log group per web API. And we only have one web API. It's not a log group per endpoint now. At least I don't think it is. I'm not sure about that. There may be a log group per backend, but either way, here's the log stream, and so this is the log stream now of the Lambda itself. Yeah, sorry, there's a log group per Lambda. Okay, there isn't a log group associated with the web API. The log group is associated with the Lambda. So here's the log stream that was generated by my post, and this part of the log stream is linked to the console log in my at the beginning of the function. So if I this is kind of the non-serialized version of the event object, which clearly we can't make any sense of. But if we expand this, then here's the full event object that is available to our Lambda function. And it has all of the Uh, First of all, we can see that the path is slash to-dos. The method was a post method. Here are actually all the headers. These are the headers that were generated by the Postman, because Postman is my client in this case. But if it was a browser, it came from a browser, these would be the browser generated HTTP headers, or potentially if you had a React app, for example, running inside a browser, and the React app generates some headers as well. You'll get them here either way. We're not interested in those right now, but if we keep going down to let's see, here's the body of the original HTTP request. Now it is serialized, so you do need to parse that. It's a string essentially, right? You do need to parse that, but we can do that in our Lambda function, and you will be doing that in the labs kind of later on. So the first thing I guess is that you need to be aware that the payload of the HTTP request, it isn't parsed for you by API Gateway. It just stringifies it, if you like, and you have to parse it. A lot of the stuff here, we probably never use, but there are edge cases when it may be useful. If I send a GET request with a path parameter, sorry, if I go back to my slides. So I want to send a GET request where there's a path parameter within the request, and presumably the Lambda needs to be able to access the value because this is a variable. It needs to access that value, and in real life, it would probably use it to, query my database or get an item from the database. So how do we get at that from within our Lambda? So here's, let's say, the GET request. So it's /movie/1234. So 1234 is our movie, sorry, our to-do ID. And I also have some, just for illustration purposes, I have a query string as well, right? Now, the key value pairs of the query string don't make a lot of sense in this case, but all I'm really interested in is how do we get at that query string from within our Lambda? Okay, so let's send. So it reached the Lambda, it looks like, because we got the success back. But really, it's the CloudWatch is where we're interested in. So if I go back to my log groups. And because there was a delay between the first and the second request, there's a separate log stream for it. And this is the log stream, I think. Again, if we blow this up, so /movies/to-do, so that's the actual path. It was, sorry, this is the path. Oh, resource, okay. Yeah, that makes sense. That's the resource of the endpoint. The actual path has the actual to-do number. But okay, you could extract it, in the Lambda, you could try and extract the 1, 2, 3, 4 from this string. That wouldn't be difficult, but it sounds like an unnecessary step, and you actually don't have to do that, because if you look down through the object, the event object somewhere, you can see this part here. So what API Gateway has done is it has extracted the, well, there's only a single variable in this case, but there could be more than one variable in the path itself. And it has put it into a nice object for us so that we can process that within our Lambda code. So we just need to access this property within the event object and realize then that the value associated with this property is an object with key value pairs, and the keys are actually match the name of our path variable. The query string part is available to us here. It seems to be in two places actually, but here's where we can access the query string key value pairs. So there's no parsing or deserializing necessary within the Lambda. Okay, so that's that. Demo API gateway, that's all right. We've talked about that. That's just excerpts from the code. We've done that. Here I'm just reinforcing what I've just shown you there, that when you're using this, the Lambda integration, Lambda proxy, or Lambda integration, whatever you want to call it, AWS proxy, is it called that as well? Maybe it is. When you're using that, then what that integration functionality within the API gateway service, it will extract it will essentially parse the query string of the HTTP request. It'll parse that up into its key value pairs and put it into an object within the event object, and we've just seen that. Similarly, for the path variables, the to-do ID in our case, it'll carry out a similar kind of pre-processing, if you like, for you. API Gateway does all of that. I know some of you have already certainly started this, if not walked through all of it, which is good. So this does have actual fleshed out lambdas and a backend database, and I think it's still sticking with the movie database context. Yeah, so this is the kind of architecture that we are creating in the lab. We have two lambdas, but now there's an API gateway in front of them. Previously, each of these lambdas had their own URL, and we triggered them directly, if you like. But now with API gateway, there's a sort of a single entry point to our functionality, and we've got a database at the back end. Just sort of reminding myself as to what's in the lab. That's okay, I think. All right. I am actually finished for today. Are there any questions, I wonder? No? All right. We'll leave it at that. And I'll talk to you in the labs next week. Bye-bye now.